Section 3.6, our objective today is I understand and use inductive reasoning and deductive reasoning. So first, our definitions. What is inductive reasoning? Well, inductive reasoning is reasoning based on observation. So it's based on observations of past occurrences, based on, another way to say it, it's based on observed patterns. Okay. And the important thing about inductive reasoning is that your conclusions are not always true. Okay? As opposed to deductive reasoning, and that is reasoning based on accepted statements, theorems, postulates, definitions, and given information. Okay? And deductive reasoning must be true if the hypothesis is true. So deductive reasoning conclusions must be true if the hypothesis is true. Okay? So for instance, an example. Whoops. Example. All right. Let's say the first 6 days of class in honors geometry. Homework was assigned each night. So you conclude, because of the observed pattern, you conclude that you will have homework every night in for your geometry class. Okay? And this is an example of inductive reasoning because you're observing a pattern that has happened, and so you're assuming that that pattern is going to continue forever. Okay? As opposed to observing that angle 1 and angle 2 are vertical angles. And so then concluding that angle 1 must be congruent to angle 2. That is an example of inductive reasoning because we are concluding angle 1 is congruent to angle 2 it's an example of deductive reasoning, because we are concluding that angle 1 is congruent to angle 2 because of the vertical angle theorem. So we are using a theorem there to determine our conclusion. So deductive reasoning must always be true. Okay, inductive reasoning may or may not be true. Okay. Example. Jose did an assignment where he measured the sums of exterior, got my R there, exterior angles of several polygons. Okay? He noticed that he always got the same result. So he concludes that the sum of exterior angles of a polygon is 360. Now in this instance, he's observing a pattern. He's not applying a definition, a theorem, a postulate, a given statement. He's observing something happening. So this is an example of inductive reasoning, because he's observing the pattern. Okay? Example 2, Laura is told that measure of angle A equals 150 and measure of angle B equals 30. Since she knows the definition of supplementary angles, she concludes that angle A is supplementary to angle B. Okay? And so this is an example because she's using a known definition. This is an example of deductive reasoning. Okay? Alright, so very often in math we use inductive reasoning to determine the patterns of things. Okay, so for instance, if I gave you the list of the sequence of numbers 3, 7, 13, 21, and I asked you to find the next two numbers in the sequence, well, you would look at it and try to find a pattern, and you might conclude then that each time from 1 to 3 you're going up by 2, then 4, and then 6, and then 8. And so you see that pattern, so then you would conclude that the next number probably should be 31 if the pattern continues. And because then it would go up by 10. And then the next number, if the pattern continues, should go up by 12. So the next number you conclude would be 43. So that's an example of inductive reasoning. Okay. Right, so if I gave you the sequence of numbers 81, 27, 9, and 3, well, you would notice that they are going down in value, and actually 87 divided by 3 gives you 27, 27 divided by 3 gives you 9, 9 divided by 3 gives you 3, then you would conclude inductively that the next number probably should be 1, and then the number after that should be 1/3. Okay? All right. So in the next example, I'm going to give you 2 statements. As given information. In other words, the 2 statements are true. State a conclusion based on deductive reasoning. If no conclusion is possible, say no conclusion. Okay? So, number 1. Angle A is congruent to angle B. Measure of angle A is 72. So we can conclude by definition of congruence that measure of angle B is 72. Using deductive reasoning, I applied a definition and was able to come to a conclusion. Okay. Number 2. All football tackles weigh at least 200 pounds. Eric weighs 210 pounds. Okay? In this situation, we cannot come to a conclusion, so there's no conclusion. Because our football tackle's the only people that weigh 200 pounds. No. Okay? So we cannot conclude that Eric is a tackle on the football team. Okay? Example 3. All cows eat grass. Blossom eats grass. This is another example of no conclusion. Oops, can't spell today. Because cows are not the only animals that eat grass. Blossom could be a goat. Blossom could be a donkey, okay? So this is an example of no conclusion. And last example, segment AB is parallel to segment CD. And so then, CD is parallel to segment EF, okay? And so by the transitive property, we can conclude that AB is parallel to EF. Segment AB is parallel to EF. So again, remember that the difference between inductive and deductive reasoning, inductive is based on patterns, and it's not always true. Deductive is based on statements, theorems, postulates, definitions, and given information, and your conclusion must be true if the hypothesis is true.